day, viewers. Welcome back to Sunky Maths class. In today's lesson, we are going to be talking of circle theorems part 2. Remember that in my last video, I discussed about circle theorem part 1, of which I stated 5 theorems on it. So today we will continue from there. Okay, so let's start with that. Now the 6th theorem states that a tangent is perpendicular to the radius at the point of contact. A tangent is perpendicular to the radius at the point of contact. What does that mean mathematically? Let's consider a circle. We know that half of a circle is known as the diameter, right? So this is my center O. Then half of the diameter is known as the what? The radius. So this is the radius here, and this is a tangent here. Okay, so at the point of contact between the tangent and the radius, they are said to be perpendicular to each other. That means at 90 degrees. So let me put that in words now. A tangent is perpendicular to a radius at the point of contact. Okay, so let's take the 7th theorem. The 7th theorem says that the angle between the tangent to a circle and a chord through the point of contact is equal to the angle in the alternative of segment. Again, the theorem states that the angle between the tangent to a circle and a chord through the point of contact is equal to the angle in the alternative of segment. So what does that mean again? We consider circle, of which we know what a chord is. A chord is a line that cuts part of the circle but not divided into 2 equal parts. Okay, so this is a chord and this is my tangent. So this chord here will make another chord to form a triangle inside the circle. So whatever angle I have here, which is the alternate, the angle I have here, which is the angle between the chord and the tangent, will be equal to the alternate segment here. So if I have x here, here is going to be what? X. So let me put that in words too. The angle between the tangent to a circle and a chord through the point of contact is equal to angle in the alternate segment. So that is what the 7th theorem is all about. So the 8th theorem now. Okay. So now, the 8th theorem is actually dealing with a length. 8, 9, 10, they are dealing with length. So let me consider a diagram before stating the theorems. So let's consider 2 chords. This is a chord and this is a chord. They intercept outside. So if I call this point P, point Q, P, T, S, and R, and I have another circle here, but they are not intercepting outside, they are intercepting within the circle. This is my intercept Q, don't forget. And this is P, T, S, and what? R. As usual. So when you have 2 chords intercepting outside the circle or inside the circle, the length of this to this, PQ, multiplying TQ will be equals to SQ multiplying RQ. That is just a simple definition. So when you have 2 chords interacting outside, this is what you are going to have, just to calculate the length. So that if you are given this one, you are given this one, you are given this one, you have to look for this one, then you divide both sides by what? By this. So that is what the theorem is all about. Then theorem 9. Okay, we consider circle too, but here we are considering a tangent and a chord. Okay, so this is my tangent and this is my chord, but this chord here is being elongated out, so we won't call it chord, we'll call it a secant. Let me intercept this. So this is actually a secant. It's a chord. This is Q, T for example, and this is S, and this is what? R. So from here to here is the chord, but this chord is being elongated outside to meet this tangent at the point. So we call this QS, we call this a secant. Okay, so the theorem simply states that the tangent squared, which is SR squared, will be equals to the length from here to here, that is QS multiplying TS or ST. So that is what this theorem is all about. So when you have a tangent and you have a chord, that's a secant, which is secant QS, intersecting the tangent at a particular point here. So the length square of this one, which is SR squared, will be equals to QS multiplied by what? ST. Okay, so the last one 10. Okay, it's also dealing with length too. So let me do that. But we are dealing with two tangents here. So this is a tangent, and this is another tangent. They intersect at this point. So look at, they intersect at this point with center O. Then of course, don't forget theorem 6. When you have a radius and a tangent, the angle there is 90. Same here too, 90. So when you have something like this, of which the two tangents, they meet at a point. So the length of the tangent will be the same, their angles will be the same, all through. So if I call this S, T, and R, so that means I can make assumption here that STO, this is center O, angle STO would be equals to angle RTO. TO. Are we together? Let me use the same thing, same format for this. Okay, so also TOR will be equals to TOS. Are we together? Then the length ST will be equals to RT. Then also generally angle S will be equals to angle R, everything equals to 90 degrees because they are 90. Okay, so this is the theorem so far on circle theorems. So try to be conversant with my first part of circle theorems. When I state 5 theorems, then this is the other part. So I'll see you guys in my next class. But if you have a question, you can drop in the comment section. And if you are new to this channel, please kindly subscribe to the YouTube channel to get more updates about my coming videos. Because the next video I'm going to release on it will be based on calculation on how to solve circle theorems. Bye for now.